Now refraction through prism. You know, prism is like this. This is a triangular prism. Prism is of so many types, but out of that I am talking about only triangular prism. You see, this is a triangular prism. There is three rectangular planes touching each other. So it consists of three rectangular planes touching each other. Plane number 1 is A, C, D, F. This is F. This is plane 1. Number 2, C, D, E, B. This plane C, D, E, B. This is another plane, and this is base. Base is another plane. This is A, B, E, F. So these are the three rectangular planes touching each other. This forms a triangular prism. Now if I see it from this side, it looks like this. Look like this. One face is this, other face is this, and base is this. So these are the two refracting surfaces, and this is base. You may take this as base, then these two will be refracting surfaces. So you can say there are three surfaces in the prism. Any two surfaces can be taken as refracting surface, and third face is taken as base. So if face 1 and 2 is taken as a refracting surface, then this face third is taken to be base. So face 1 and 2 refracting surface, and face 3 we used to say base of prism. Now these two refracting surfaces meet here. So this angle between the two refracting surfaces is called angle of prism, and it is denoted by capital letter A. Angle between two refracting surfaces is said to be prism angle. So when prism is kept like this, prism angle will be this. If you take base this, then prism angle will be this. If you take base this, then prism angle will be this. So prism angle is angle opposite to base. This is base, so angle opposite to this base is this. This is called prism angle. If these two angles are equal, suppose this angle is theta, this angle is also theta, then we used to say that this prism is symmetric prism. If this angle and this angle are same, then prism is said to be symmetric prism. Otherwise, asymmetric prism. So the prism about which we talk, that is symmetric prism. We don't talk about asymmetric prism here. Now, a refraction through prism. Suppose this is refracting surface 1. This is refracting surface 2. And this is base of prism. So this is base, and these two are the refracting surfaces. So angle opposite to base is called prism angle. So this angle I say angle of prism, denoted by capital A. This is first refracting surface, this is second refracting surface, and it is a symmetrical prism. So if I incident a light on first refracting surface, this is normal on first refracting surface. So I say it N1, and let light is incident on this surface. This is a monochromatic light incident on the surface. This angle is said to be angle of incidence. This is the original path of light. If I take air, and this is material of prism whose refractive index is mu. So light is going from rarer to denser medium, so it will bend towards normal. So it will not follow this path, it will go like this. Suppose it hit second refracting surface here. This point, let it be point P. If I draw normal here, let this be normal at this point. Extend these two normal. Let these two normal meet here. This point be Q. Now light will not go like this because it is going from denser to rarer medium, so it will go away from normal. So it will go like this. This ray is called emergent ray. Emergent ray. This ray is called incident ray. Incident ray. And ray PQ, this ray is called refracted ray. Ray PQ is called refracted ray. Refracted ray. This is normal and this is refracted ray, so this is angle of refraction at first surface. This is refracted ray, this is normal, so this is called angle of refraction at second surface. Let it be R2. This is normal. And this is emergent ray. So this whole angle is said to be emergent angle, angle of emergence E. This whole angle is angle of emergence. This point is P, this point is Q, let this point be R, and this point be S. Then there is a quadrilateral R, P, S, Q, R. So this is a quadrilateral, and this quadrilateral is cyclic quadrilateral because this angle is 90 degree and this angle is also 90 degree. Sum of opposite angle is, if in quadrilateral sum of opposite angles are 180 degree, then such quadrilateral is said to be cyclic quadrilateral. So here this angle RPS, angle RPS and angle SQR, these two angles are 90 degree each and they are opposite to each other. Hence this quadrilateral PSQR is a cyclic quadrilateral. If sum of this and this angle is 180 degree, then sum of this and this angle must also be equal to 180 degree, because in quadrilateral sum of all four angles are 360 degree. So here you can write in quadrilateral P, Q, P, S, Q, R, that is cyclic quadrilateral, sum of angle A, this angle and this angle, I say this angle as angle S, is equal to 180 degree. And in triangle PSQ, in triangle PSQ, angle R1 plus angle R2 plus angle S must be equal to 180 degree. In triangle PSQ, angle R1 plus angle R2 plus angle S should be equal to 180 degree, because sum of all three angles in a triangle is 180 degree. So from equation 1 and equation 2, right hand side is equal, hence left hand side can be equated. So we can write from equation 1 and 2, angle A plus angle S should be equal to angle R1 plus angle R2 plus angle S. So angle S cancel. So what is left? Angle A is equal to angle R1 plus angle R2. So now I am writing A is equal to, this is angle A is equal to angle R1 plus angle R2. So this is important result, remember this formula. This angle plus this angle is equal to this angle. Angle R1 plus angle R2 is equal to angle A, and this comes from geometry, simple geometry. I have used 9th standard geometry, you know. Now see here, light should have gone like this, but it is going like this. So light has deviated this much from its original path, and this angle of deviation delta 1 and R1, sum of these two angles must be equal to I, vertically opposite. So from this diagram we can say that delta 1 plus R1 is equal to I. We can say that delta 1 plus R1 is equal to I, hence delta 1 is equal to I minus R1. What is delta 1? Deviation at first refraction. Deviation at first refraction. So this we know. Let this be equation 3. Similarly here, light is going like this, so it should have gone like this, but actually it is going from here. So this angle is deviation at second surface. Now you know this angle is equal to this angle vertically opposite. So this angle is equal to R2. It means R2 plus delta 2 is equal to this whole angle, that is angle of emergence. So we can write delta 2 plus R2 is equal to E. So angle of deviation at second surface is E minus R2. So at first surface light is deviated by this much clockwise, at second surface light is deviated by this much again clockwise. So what is total deviation? Total deviation. So total deviation is sum of delta 1 and delta 2, because both are clockwise. So we can write I minus R1 plus E minus R2. This is total deviation. So from this equation total deviation we can write like this: I plus E minus R1 minus R2, that is I plus E minus R1 plus R2, and we know already R1 plus R2 is angle of prism A. So total deviation is I plus E minus A. So this is another important formula you should remember. So regarding prism, two expressions I have derived, and both I derived by using simple geometry, no physics. So I am writing these two important formula here. First important formula is A is equal to R1 plus R2, and second, total deviation is equal to I plus E minus A. So these are the two important formula in prism that we always should remember, and that is derived from geometry of the prism. Define angle of deviation. Angle of deviation. What is the angle of deviation? See, this is the direction of incident ray, and this is the direction of emergent ray. So this angle is angle of deviation. Angle of deviation is angle between direction of emergent ray and direction of incident ray, or in other words, how you can say how much incident ray is turned by prism while passing through it. So it is angle by which incident ray turns while passing through prism by the prism. This is definition of angle of deviation. We can also define it like this: it is angle between direction of incident ray and direction of emergent ray. So, or it is angle between direction of incident ray and direction of emergent ray. And its formula is, this is angle of deviation is equal to I plus E minus A, or you can say that sum of angle of deviation and angle of prism is equal to sum of angle of incidence and angle of emergence. Let us see one question on angle of deviation. It is given that angle of prism is 30 degree and angle of incidence is equal to angle of emergence, and angle of emergence is 3/4 times angle of prism, that is also given. Then find angle of deviation produced by prism. This is to be calculated. So see, angle of deviation is equal to I plus E minus A. I and E both are equal, so here I am going to write I. So I plus I 2I minus A, or we can write it 2E minus A, because I and E both are equal. Now E is equal to 3/4 times A, so at place of E we can write 3/4 A minus A, so it is 3/2 minus 1 into A. 3/2 means 1.5, so it is 1.5 minus 1 into A, and A is 30 degree. So this is 1.5 minus 1, that is 0.5 into 30 degree, so this is 15 degree. So deviation is 15 degree in this case.